Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. This is Dr. Azrul speaking. And inshallah, good news. Today we will complete and finish our chapter and summarize on what we have learned so far in abstract class and interface. In general, both approach have their own implementation technique and benefits to the program. However, the features provided were a little bit different. First of all, an abstract class can have all the data types, whereas in interface the data can only be a constant. Abstract class has the option to include abstract methods and concrete methods. The first is only to provide the signature of methods, while the latter can provide implementation details. However, interface can only provide method signatures without implementation body. The following table illustrates more details about variables, constructors, and methods. Okay, according to the previous table, all variables in an interface must be in public, static, and final type. In addition, all methods should be public abstract, and thus these modifiers can be omitted as shown in the following example. From public static final int k is equals to 1, we can simply translate it into a simpler statement, which is int k is equals to 1, or public abstract void p method to just void p. A constant defined in an interface can be accessed using syntax interface name dot constant name. All classes share a single root, which is the object class, but there is no single root for interface. A variable of an interface type can reference any instance of the class that implements the interface. If a class extends an interface, then this interface will react just like a superclass. And finally, you can use an interface as the data type and cast a variable of an interface type to its subclass and vice versa. The following diagram shows the relationship between classes and interface, which define with inheritance association. If you still can remember the small triangle shape in red in color, okay, the inheritance association. In this case, says we define an object or instance called C that belongs to class 2. At the same time, C is also an object or instance which have access privilege to access object class 1, interface 1, interface 1.1, interface 1.2, interface 2.1, and interface 2.2. And how can you summarize this diagram? Do you think that the same case will happen if the interface represented in this diagram change to abstract class? To answer this question, please perform a simple exercise, a simple hands-on on your Eclipse editor to prove your answer. Without a single effort on doing programming with a simple coding, you won't get the answer. Okay? Okay, guys. Sometimes a class not only implements a single interface in its program, but it may implement more than one interface. Just an important note here is that you have to be careful if those implemented interface, for example, interface 1 and interface 2, hold the same variables or constant in its definition, or there are two or more methods with the same signature but different return type, or even input parameter. An error or exception could be detected by the compiler using compilation time. After looking into the details of abstract class and interface, which of the following that will influence you more during coding implementation? I mean, do you wish to use interface or abstract class? How you decide it? Okay, this is I've got some guidelines here. If you are engaging and dealing with common and general program with common features, then abstract class and interface can both be used. No problem at all, and you could choose either one. Alright? However, if your program consists of a strong or weak relationship, then you have to identify the best implementation using abstract class or interface. Okay, listen carefully. According to the chapter inheritance, which we have learned long time ago, a strong is a relationship of a class can be represented by composition, while a weak is a or has a relationship can be represented by aggregation. And therefore, a strong is a relationship that clearly describes a parent-child relationship should be modeled using abstract class. And a weak is a or has a relationship, or also known as is kind of a relationship, can be modeled using interface. To explain this, we better to look into another example. Okay, the following example illustrates an example on how you are able to construct your own custom interface. By looking at the example, we found that there is only one specific interface called edible. This interface includes one concrete method called public string how to eat method that will be implemented by any classes which implement this interface. In general, there are 6 classes in the example, namely animal, chicken, tiger, fruit, apple, and orange. From these 6 classes, only one class which we declare as an abstract class, which is a fruit, while the remaining declared as concrete classes. Please observe the example on how to eat methods being implemented by those classes. Perhaps to have a clear view, you may try to draw UML diagram to illustrate the relationships and association in easier way. In the following example, the program explains how you can implement more than one interface. As we refer to the previous example, interface edible only includes one method called how to eat, while interface comparable only includes compare to methods in it. And therefore, when we construct a program that implements both edible and comparable interface, we must implement both of their methods as well. As you can see in the program, there are implementation on how to eat methods which returning fry it, and compare to method that return the weight of a chicken objects. And now we move to the next program example. We may ignore the interface edible declaration at the top of the program, since we are focusing on the class test edible and show object method. We have the main method that construct, we have a main method that construct an array list, if you can see in the program, to hold several numbers of objects from class tiger, class chicken, and class apple. After all the objects were kept in the array list, we have a for loop statement that to invoke each object towards show object method. The invocation of a show object method will first to check whether each object was an instance of the edible interface. If yes, then the program will invoke the how to eat method and produce output. From this example, we can observe the relationship between classes and interface, and perhaps how we are able to construct and execute methods from the interface. Okay, we are at the end of the chapter. This slide summarizes all contents that we have learned in abstract class and interface. It describes the features and characteristics of abstract class and interface which you have learned previously. There are plenty of examples that you might use and execute to show the significance of abstract class and interface. Once you can understand the difference and implementation of both approach, then you are absolutely going good. With this summary, we end up our session for today, and we have completed our chapter. Alhamdulillah. Okay, keep in mind, please do hands-on and try to do some exercise to strengthen your knowledge in this topic, especially during your lab hour. Okay, I cannot control your lab hour, but the only person can control the lab hour is you are the person. Okay, this is Dr. Azrul. Thank you for watching and listening. We will continue with a new chapter later. Stay safe and stay healthy. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.